So in find zor, what do we have to do is this is an interactive problem. Okay, so we are not given a sequence a1 a2 an, but you have to find a1s or a2s or up to an. But how do you find it? So you have to ask a query which will be k, and it has to be less than 2 into 10 to the power 6, and you will get the response with this thing, right? So I'm assuming you have read the question. What we do is, how do we find these numbers? So one thing interesting, first observation, 10 to the power 6. 10 to the power 6 has 20 bits. 20 question, 20 bits, very convenient. And also second observation is XOR can never increase the number of bits. It can decrease the number of bits. When I'm saying bits, that is the maximum number of bits you need to represent the number. For example, for 5 we need 101, but for 3 we need only 2. So across all the numbers, the maximum number of bits which we need is 20, because it is till 10 to the power 6, right? So that's it. So that is first observation. So time for next observation. So now suppose you have one left shift 20, it will actually have 1 and then 20 zeros, right? So basically, if you XOR it with any number which is less than 10 to the power 6, this one will remain unaffected and all the numbers will remain unaffected. So for example, let's look at a smaller example. So suppose we have 3 bits. In our case, this is 20, which is 10 to the power 6 thing. And suppose I'm XORing it with 1 to the power 20. So suppose my first query is this: 1 left shift 20. Now what it does is basically it goes to every number and it just appends 1. So this is the first query, and what will I get as answer is basically the sum of all those individual XORs. So if you notice, what has happened here is, for every number I have added 2 raised to the power 20 to it. That's it. So now when I get a reply from the interactor, or whatever it is called, so it is called interactor. So you get a reply with the interactor. So what is happening is, reply will be equal to original sum plus n times 2 raised to the power 20. From here I get sum, right? So that's the first query. So I'll not try to tell you how I came up with the solution, because it was mostly hit and trial. But first thing is that there are 20 questions and 20 bits, and I try to figure out how can I figure out 1 bit and 1 question, right? So that's it. So we have one query, we got sum. Now we have 19 queries, but we have 20 bits. But let's see, right? So we have sum, and so now suppose in one query I want to find what will be the ith bit of a1 XOR a2 XOR a3 up to an, right? So this is what I want to find. So if you look at XOR, suppose I'm XORing some numbers. So if I XOR, when will be the bit of this XOR 1? When the number of ones at a particular location is odd. So in this case it will be 0. In this case it will be 1. Right? So I was XORing 1 0 1 1 0 1 and 1 1 0. So in second space there is only 1 1. So here it will be 1. So something like that. So in every position, if I can tell if there are odd number of zeros or odd number of ones or even number of ones, then I can directly tell what will be the XOR of them. If it is odd, it will be odd. If it is even, it will be 0. If it is odd, then it will be 1. If it is even, then it will be 0. Right? So we will try to figure out how can we do this. So suppose I am making a query which is 1 left shift I, basically 2 raised to the power I. Right? So notice what happens here. So the number here is 8, number here is 12, number here is 6. So if I make a query which is 2 raised to the power 2, which is 1 left shift 2, then what happens is it goes to this position, right? So if we start from right side and say 0 1 2, so it goes to second position or second index, and it actually turns 0 to 1 and 1 to 0, right? That is what this XOR will do, because we will be XORing individual elements and then summing them. So notice, if it is a 0, then it will be converted to 1. Then actually we will be adding 2 raised to the power I into the number. If it is 1, then I will actually be subtracting 2 raised to the power I. For our case, I is equal to 2. So for how many bits we have shifted it, right? So if for any I can do this. So what will be the reply to me in this case? It will be equal to sum, now notice, plus how many times we will add it. 2 raised to the power I times how many zeros were there. minus 2 raised to power I, and how many times ones were there. So I get the reply, I get the sum, and I know 2 raised to power I because I have interacted. So basically at a position I have got number of zeros minus number of ones, which is equal to this thing, reply minus sum divided by the power of 2, right? So that will be reply minus sum divided by power. And what is 0 plus 1? This we already know, it is all the numbers, so which will be equal to n. So now we have two equations, which is 0 minus 1 is some constant, 0 minus 1 is some constant, 0 plus 1 is n. So using these two equations and in two variables, we can find the number of ones in that thing, right? So basically you subtract this from this or something like that. So basically you should know how to solve two equations in two variables. So we get the number of ones in this position. So I'll just do it for one case. So the sum of these numbers were 26. When I did XOR, 8 becomes 12, this becomes 8, so 20, this becomes 2, so 22. So the difference is 4, and the power is 4, so the difference is actually 1. That means number of ones minus number of zeros. Oh wait, it should be opposite, right? So I'm decreasing, so it is minus 4. So number of ones, so number of zeros minus number of ones is equal to minus 4, minus 1, sorry. What was it? Yeah, it was difference was minus 4, but when we divided it with power, which is 4, it becomes minus 1. So 0 minus number of ones is equal to minus 1, and 0 plus ones is equal to 4, is equal to 3 in our case. So basically you can figure out that zeros is equal to 1 and ones is equal to 2, which is correct because we have 1 0 and 2 ones. So at this position we have two ones, so the XOR will contain 0 at this position. So that's it. So that I'll just clear it a bit. So this way I told you how in one query you can figure out at any ith position if there are even number of, so basically you can figure out how many ones are there. So then you can just check if it is odd, then in the answer that bit will be set to 1. If it is even, then it will be set to 0. So that's it. But we have only 19 queries, right? So how will we figure out the 20th bit? So the thing is that you can get that bit from sum itself. How? So when you are summing some numbers, right, the last bit will actually be either even or odd based on the number of ones in this column. So suppose there were two ones, this will become 0. If it was 3, then it will become 1. So by the parity of sum, you can figure out what will be the parity of the answer itself, right? So basically if you are only talking about one bit number, then XOR is actually sum modulo 2. So that's why the last bit you can figure out from sum itself. Last bit of XOR will be equal to the last bit of sum modulo 2, which will in base 2 it will be actually the last bit of sum itself. So just to reiterate, so the last bit will be, if there are even number of ones, the sum would have been 1, and sum would have been even. So number of ones is even, so sum is even, so the XOR will also be even, right? So something like that. So that's how you figure out the 20th bit. So that's it for this question. Implementation is not that tricky, so it is easy. The first query is, as I mentioned, 1 raised to power 20, and from that reply I'm getting the sum, right? And I'm getting the sum, and answer is basically reply modulo 2. So that is the first bit, as I mentioned, right? This will get me the first bit. Now I can make 19 questions. In every question I'm getting a reply and I'm solving it that way. So I find diff, which is reply minus sum, and I'm dividing it by power, as I mentioned, right? I erased it, but so we are dividing it by power, and then we have two equations. Zeros plus ones is equal to n, so this should be n, and zeros minus ones equal to diff, and when you solve you can count how many ones there are, and we are just returning the parity of ones. And that way, when it is parity is 1, basically the number of ones is odd, then we actually set that bit, and then that's it. So implementation is not that tricky, it's mostly about observations. So that's it. So hope that was helpful. Thank you.